Welcome students. This is the third lecture on graph theory. Hope you have seen the previous two lectures. It helps you to understand this lecture. Let us begin with definition of odd and even vertex. In a graph G, a vertex is said to be odd vertex if the degree of the vertex is odd. A vertex is said to be even vertex if the degree of the vertex is even. In this picture, V1, V2, V5, V6 are even vertices. V3 and V4 are odd vertices. Now we can make the conclusion. The number of odd vertices in a graph is even. Let G be a graph. Let summation all dvi equals to the sum of all degrees of all vertices. Summation even dvi equals to the sum of all degrees of all even vertices. And summation odd dvi equals to the sum of all degrees of all odd vertices. Therefore, summation even plus odd dvi equals to summation all dvi implies summation odd dvi equals to an even number. Therefore the number of odd vertices in a graph is even. Now, we show that the maximum number of edges in a simple graph with n vertices is n into n minus 1 by 2. To prove this, let G be a simple graph with n vertices. Since G is simple, then the maximum number of edges between two vertices is 1 and no vertex has self-loop. Therefore the maximum number of edges is nc2 equals to n into n minus 1 by 2. Lastly, we show that the maximum degree of any vertex in a simple graph with n vertices is n minus 1. To prove this, let G be a simple graph with n vertices. Since G is simple, then the maximum number of edges between two vertices is 1 and no vertex has self-loop. Therefore the maximum degree of any vertex is n minus 1. You can note down these definitions. If you have any query regarding this explanation, you can write down in the comments section.